Number 4 should be factorial. Number 12, I think you were finding like the first 4 terms or something, right? Should be 3. Now you could have written them like this, or you could have them with commas. It's a sequence, true? So 3 comma 12 11ths comma 9 13ths comma 24 47ths comma 15 37ths. The first 4, oh, first 5 terms. I apologize. First 5 terms. Number 22, also looking for the first 5 terms. What did this -1 do, guys? Well, it did something pretty important though, right?
It was either -1 or positive.
Yeah, and it alternated. That's actually a technical term for it. We call this an alternating sequence. And like calculus BC, alternating, which might make sense with alternating between positive and negative. If you hear alternating in terms of series or sequences, it's talking about the sign, the positive and negative. Now, if you know what car is the alternator, I wonder if that has something to do with alternating. Alternator. Anyway, but 1/2, -1/5, positive 1/10, -1/17, and positive 1/26. Yeah, that -1 just alternated the sign. Number 34, you were looking for specific terms. Oh, no, you're just matching. Sorry, this is how they made it match. It was letter B. I apologize. 34 is just letter B. I'm trying to get rid of that annoying. Why is that coming up? Go away. Okay. Number 60, looking for the first 5, except in this case, starting or looking for the first 5, didn't it say start with n equals 0? So it was A0 through A4. And you were practicing with factorials. It would have been 1, 1/3, 2/5, 6/7, and 8/3. Remember, they were reducing or trying to reduce if possible. You couldn't really reduce very many. Oh, you couldn't reduce any of these ones. That's no fun. But in number 64, aha! You were able to have all sorts of fun. Now, if you guys were party poopers and just threw that in your calculator, shame on you. We were trying to figure out and get the feel for factorials. And this could be on a non-calculated portion of a test. Ooh, really? Yes! Because I don't expect you to find 12 times 11 times 10 times 9 times 8 times 7 times 6 times... No! Because you could have reduced big old chunks of this guy. Because 12 factorial is 1 through 12. 4 factorial is 1 through 4. Well, those could have been gone. 8 factorial has, well, okay, there was another set of 1 through 4 that wouldn't have canceled, but 5, 6, 7, 8 would have canceled. And then you get all kinds of fun being like, okay, well, hold on. I've gotten done or rid of 1 through 8, but I could have some fun in the sense of can reduce with 10, 3 can reduce with 9, and 4 can reduce with 12. And so you could have done some reducing, which is what they did. So they reduced 2 and 10. They actually went ahead and said, well, 3 times 4 is 12. Ha-ha! So they did 9 times 5, 45, 45 times 11, 485. That wasn't too bad. If you did it the reduction way, trying to take out as many terms, reduce as many terms as possible. This one was weird. This one was weird. But both of them, in some way, shape, or form, oh, that's a typo. I apologize. That's not legal. Hold on. Guys, do you see the typo in number 66? How should that have been written? Yeah, the factorial should have been on the outside. There should be a parenthesis and then a factorial. Otherwise, 2n plus 1 factorial is just 2n plus 1. That's boring. But both of them are being measured by 2n. Just this guy, all the numbers 1 through 2n fell 1 short. This guy fell 1 short of 2n. And this guy went 1 past 2n. Show this guy falling short of 2n and this guy going past 2n. All of these guys end up reducing away, and all that's left is the 2n that the bottom had, the top didn't, and then the 2n plus 1 the bottom had that the top didn't. But sorry about that typo. Well, I guess you guys didn't see it in Calc Chat anyway, though, or in the answer key, because it's an even. But anyway, good catch on that typo. And then number 94. Number 94 was a fun one. He was a repeating decimal. Sorry. 1/10 plus 100th plus 1,000th plus a 10,000th plus was the same thing as 0.1, 0.01, 0.001. It ends up being 0.111, which is 1/9. An infinite sum encapsulated or held within a finite fraction. Whoa. All right, section 9.2. We went to arithmetic sequences and series yesterday. Those were the notes that I just copied in from. I can actually close out this. That was last year's notes. Let me make sure I got them all copied in. I should have done that before I erased them all. There we go. Arithmetic, really quickly. What's the pattern? What's the common piece? Common difference. Yeah, common difference, D. And then somebody said sum. That is true, except why isn't it called the common sum? Why is it called the common difference? Did anybody pick that out yesterday? To find it, you subtract, yeah. So you add to go forward, but to find what happened, to find what's in between, the common thing is not what happens when you add the terms together, but when you subtract the terms. We're not adding the terms together, we're adding a constant. So the way you find that constant, what's in common is what's between them. And you can find what's between them by subtraction. So we did a lot of different things yesterday, we meaning a very past me, not a present me, but either way. Me nonetheless. We figured out how to work with common differences, how to get to equations to find who's a sub n again? It's a formula for the nth term. Good. It's a formula for the nth term. So jumping to the 10th or the 20th or the 50th spot. But not only for the nth term, wasn't there another formula also yesterday? Yeah, S sub n. And S sub n is the nth partial sum. Hence, the sum of the first n terms. So S sub 10, the sum of the first 10. S sub 20, the sum of the first 20. Those are series, right? Series take a sequence and add them all up. I think we did some homework help just a little bit. Oh, we didn't get to that one. Well, that's a bummer. But that was just plugging and chugging into the formula. Let's see how you guys did on this homework, and then we'll cover questions. Cool? Section 9.2, number 14. Yes, it was arithmetic. D was equal to -3. Don't say subtract 3, say -3. So you're adding a -3 every time. But yeah, arithmetic sequences can go down or go up. They can add positives or add negatives. Number 40, the first 5 terms. 200, 190, 180, 170, 160. Number 48, you were finding the 7th partial sum, plugging in 7 for n, but also needing the 7th term, the first plus the 7th, added together, divided by 2. Or by n over 2. Number 54 was also a plug and chug, but 54 was a bit harder. Did anybody figure out why 54 was a bit harder and required a bit more work? They were trying to find the 50th sum. But to find the 50th sum, does anybody have either in your notes or in your memory, what's S sub n's formula for a arithmetic sequence? N over 2 times the first plus the last. Did you guys hear about Gauss yesterday? Little Gauss, little rebel. Actually, I don't know if he was the one that's really causing problems, but from the teacher's frustration, if he came up being like, I have the right answer. I think he was being a stinker. But either way. You need the first and the last and then multiply by half. But if they wanted S sub 3, what was the problem? What'd you need? You needed the last. So could you have gone ahead and gone to 50? Okay, what are we adding? 4? Plus 4, plus 4, plus 4. I don't want to go to 50. Do you want to go to 50? So instead of actually like adding up to find the 50th term, what do you see that they did? They jumped to the 50th term using the nth term formula. So they said, oh, you know what? I guess I could adding to get to the 50th, but at that point, save. Because then I could just plug all those numbers. So instead of going to the 50th term and having to keep track of how many plus 4s you're doing, instead they're like, I can use the nth term formula to jump to the 50th term. Yay, there he is. And now I have my first, and I have my last, and then I multiply by 50 over 2. Dun, 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 dun. So sometimes in finding the nth partial sum for arithmetic, since we need the first and the last, use the nth term formula to get to the last and then plug in. So you're going to be using both formulas at the same time. This is a very good example to highlight, by the way, as far as a big idea from section 9.2. Let's go back to our answer key. You guys can see number 66 matches D. Number 68 matches A. Number 8. What was going on, and why does it look so nasty? I don't want you guys just writing down what's going on. So let's go look at number 84. Who has a question on 84 in some way, shape, or form? Okay, cool. I figured. Look, I know you guys. Aww. Oh, we should have done this, a steel ball with a negligible air resistance.
Yeah.
Being dropped from, ooh, a bomb? Anyway. Boom, that's funny. Anyway, coming back. Wyatt was slightly entertained. Guys, what are you doing? Buying a used car? Go team. Jason. Hi, buddy. Wake up. You borrow $5,000 from your parents to purchase a used car. You could buy something with $5,000. The arrangements of the loan are such that you make payments of $250 per month plus 1% interest on the unpaid balance. I think your parents are teaching you how to manage finances. Anyway, find the first year's monthly payments and the unpaid balance after each month. What'd you guys think of? What'd somebody do? Nth term formula? Where does the arithmetic sequence come in? Why is it arithmetic, though? Isn't arithmetic like plus, 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 plus? If you see the word total amount, why am I going to write an S sub n? Yeah, you're adding up what you're paying. Does that make sense? Yeah? So S sub n, you're adding up what you're paying, the total amount. Okay, so if letter B is S sub n, then what's letter A? Probably, maybe what Kyle said was A sub n, right? So if letter B was S sub n, letter A sub n. Okay, so hold on. Find the first year's monthly payments, because you're paying each month. So A1, A2. Now, it'd be really nice if we could get our calculator to do this work for us, right? But don't we have to tell our calculator something, like as far as some sort of formula, what's going on? Okay. So what am I paying each month? What are you paying the first month? That's it? $250 and? 0.01 of what? Of the unpaid balance? Because that month, how much was unpaid? Now hold on. So wait, am I doing 1% of 5,000 or am I doing 1% of 4750? Okay, so it's not after I've paid the 250, it's before I've paid the 250. Now some of you guys might be like, is that really how it works? Well, you can ask your parents about their mortgage payment or their car loans, etc., as to what they pay. But when you're paying the percentage, the APR, you're paying on at that moment for the statement that they gave you what was unpaid. They're not like, oh, you're giving me $250? Okay, cool, I'll lower your interest. No. For the next month, it'll be like, oh, okay, now your balance is $47.50 before you pay. Then your balance is your balance. Oh, hey, so what's changing every time? The unpaid balance. So what's happening to your interest that you're having to pay? Lowering. This is why some people pay above their actual payment. Like on mine for my mortgage payment. Now is why? I'm trying to decrease the length of my loan. I'm trying to pay less and less. So, lowering how much you're paying on interest every month. That's a typo. I don't know why that says 200. That's wrong. If that was right, then he would get a penalty or something. Anyway, so coming back. Is there a way we can get our calculator to do this? Does anybody have any ideas as far as how to not have to write this out 12 times? Which we could. I mean, the answer key did. But is there anything that possibly formula or something so I don't have to do this work every time? Because this would be super annoying, right? What's happening every month? It's going down by 250. So couldn't I say A sub n, how much I'm paying for a given month, is 250, that's constant, right guys? You're always paying that payment, plus 1% of, okay now, be so much easier if I could put in one nice little equation to my y1, go to my table and have my table automatically generate and get me all my numbers. So how can I mathematically express what's going on using the variable n with my 5,000 going down every month? Think about it, guys. Is Aiden right? Because the first month, wait a minute, the first month, hold on. Start at 0. Put Aiden's and Tony's together. Does it make sense? Oh, start at 0. So therefore, to make it easy in my calculator, couldn't you go to your y equals? Are you guys in sequence mode still? Okay, sequence mode, go to y equals. Do you have an option for n min? Yeah, you do. So make n min 0 because we want our payments to start when we're not taking anything off the 5,000. And you have a practical application as to when n might be 0 instead of 1. Now we could have changed our formula and made it something like minus 250 times n minus 1 and started at 1, but that's kind of awkward and it's kind of gross. And it's a lot nicer to be like, oh, you're not able to deduct anything at first, so the first payment n is equal to 0. And then can't you guys go to your table? Count 0. So you guys should be able to double check. And do your numbers match up with what they're showing here? First month you paid 300, second month, now careful, yours is A sub 0, A sub 1, A sub 2. But 297.50, 295, 292, 290, 287.50, etc. Is it working? All the way up through A12? Yeah. Well, because in theirs, they're not using their calculator. They're not making a cool formula. They're actually writing it out by hand every month. So they were like, whatever, first payment, 12th payment. They did it like the natural, logical way of thinking about it. But for us, since we're doing the 5,000 times, we're like, oh, it makes sense the first month, 5,000, or sorry, the first month, the 250. Didn't get deducted yet. So it makes more sense in our purposes to start at 0 and go A sub 0 through A11. But either way, it's the first 12.
It's still the same thing though, basically.
Yeah, same thing, just different meaning as far as the mathematical expression. Does that make sense? Cool. So then coming back, you guys' numbers should match up, but this is your A0, no, sorry, this is your A0 and that's your A12. Yeah? Now, the problem is, in letter B in my problem, it says find the total amount over the term of the loan. Is your loan paid off at A12? No. Well, I mean, closer, right? But it's not paid off yet. So if it's not paid off yet, what do we have to figure out before we can even do letter B? When it will be paid off. Okay, so think it out. If you're paying $250 a month, well, no, you're not paying $250 a month. You're paying extra, right? But how much on your loan are you paying off per month? $250. If you're paying off on your loan $250 a month, when will your loan be paid off? What's 5,000 divided by 250, guys? When are you going to be paid off? How many payments of 250 will cover the $5,000? 20? Because 25 times 2 is 50, and then add on a 0, 5,000. So 20 payments. So what are we going to do for letter B? Okay, so Kyle's trying to plug into 20 over 2. But here's the problem. If we're trying to find the sum, and we are trying to add everything together, S sub n, but it is going to be 20. Interest in this, I don't even know. Ignore that. 20 over 2. N over 2. What are we using as our first and last term? Are they asking how much you've paid, or are they asking just how much interest? Okay, so how much interest did you pay the first month? No, 300 was your entire payment, wasn't it? 300 was what you paid, so how much interest, how much of that was interest? 50. How much interest are you going to pay the last month?
Oh dear.
If you're totally paid off after your last month, what was the remaining balance that last month? A sub 20, you're paid off, you're done, the loan is over. You're paying $250 a month. What was the bill that you were paying to pay it off? No, not that last month. $5,000 puts you back at the very beginning. I know you guys haven't had to pay a lot of bills. You haven't had to pay off a lot of loans. If your A sub 20 paid off your entire loan, what was the bill? What was the statement balance that you had to? What was the bill you had to pay on that 20th month? No? Wasn't it just $250? You were paying it off. You were done. Yeah, it was just $250. You were doing the last payment. So what was your 1% of $250? What's 1% of $250? Isn't that $2.50? It's okay. You guys just made it harder than it had to be. Is that all we have to do? Or is it? Huh. Is your interest an arithmetic sequence?
Yeah.
Is it? Okay. Your interest the first month, $50, right? 1% of 5,000. What was your interest the second month? $47.50, right? What was your interest the next month? I'm just taking 1%, moving the decimal places 2 places, right? 45. Next one, 42.50. Next one, 40. Next one, 38.50. Next one. Is this arithmetic? Minus 250, minus 250, minus 250, minus 250. Why? Because what are you paying?
250.
Ah, so it is arithmetic. So all you have to do is plug in 20 over 2 times the first interest payment of $50 plus the last interest payment of your last $250, and you are done, dun, 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 dun. Woo! All right. Now, hold on. How could you figure out how much money you paid then?
20.
Find me S sub n. Find me S sub 20. What'd you guys get? What'd you get?
525.
What else were you paying every month besides interest? So how many 250s? You guys are funny. How many 250s? 20. P.S. You paid the 5,000. There you go. You guys are cute. You paid the 5,000 and you paid the 525. So how much did you actually end up paying for this used car? 5,525. The question was, was it worth an extra 525 to have the car 20 months earlier? Maybe, maybe not. Why am I asking you this question? Do some people take out loans to pay for things they can't afford in the moment? And then it takes them years to pay it off with smaller amounts? But what do those smaller amounts do? Add up to an amount way above. Now this one's only a $5,000 car. What am I talking about? 18, 80, 150, a house? You should take personal finance. All right, cool kids. Let's get back to section 9.3. Is it worth the extra money you end up paying to incur debt with loans. Ooh, credit card payments? Now we're getting real. Anyway, Jason, done with homework questions. Go stand up at the podium. Here we go. Notes open. Section 9.3. We covered, you guys might have extra questions on 9.1, 9.2. Remind me tomorrow. I don't totally mind if we go over those questions, but just for sake of today, we do need to get into section 9.3, geometric. And to that end, oh my goodness, we missed a word problem example. That's okay. We worked through the car loan one, which was way cooler anyway than beauty supply products, skincare products. Anyway, let's go to section 9.3, geometric. Jason, go. Notes. Notes, though. Do you have your notes today? Do you have your notes? Oh, where's your homework? All right, here we go. Jason, bring your homework tomorrow. I want to see it, okay? Section 9.3, geometric sequences and series. Geometric, a special sequence where the ratio of any two consecutive terms is constant. Ratio, common ratio instead of common difference. Common ratio instead of common difference. You guys can look over here and remind yourselves of what a geometric sequence looks like. Guys, what's the pattern? Plus 3 plus, no. Well, yeah, plus 3 plus 6 plus 12 plus, it's plus the previous term, but what's another way of looking at it that's constant every time? The difference isn't common. 3, 6, 12, there's a pattern. You could do second difference, but another way of looking at it is also a, no, it wouldn't be a second difference, careful. Because 3 and 6 would be 3, and then 6 and 12 would be 6, and then there's no. Okay, Gavin is saying there is a recursive. You guys remember that pattern, that book from the first? He's saying that A sub, I'm going to use K. Gavin, we use that for recursive. Oh, got it. You could do A sub K is equal to A sub K minus 1 plus, oh, you're going to the A sub n. Sorry. I thought you guys noticed, or I thought you were noticing, Gavin, my bad. Every time, 3 plus 3, 6 plus 6, 12 plus 12. Every time to get the next term, it's going to be a previous term plus itself, which is kind of weird. So to get 6, you did 3 plus 3. To get 12, you get 6 plus 6. But an easier way of doing it is just A sub n is equal to 2 times A sub n minus 1. Doesn't that just mean every time the pattern is times 2? Times 2, times 2, times 2. What does that mean? 6 over 3, 2. 12 over 6, 2. 24 over 12. Why is it called ratios? Because instead of finding the difference, instead of subtracting, you're going to be dividing. R equals 2. R, common ratio is the common constant multiplied. You can say the common multiplier if you want. Common ratio, the common multiplier, what's being multiplied every time. Wait a minute, so do geometric sequences only grow? Because if you're multiplying, you're growing, right? Well, but I wouldn't technically call it division, but yeah. The same way with arithmetic, you can add or subtract, you can increase or decrease. With these ones, you can multiply or multiply by a fraction. Multiply by a reciprocal. Now you guys already have, hopefully from writing down the beginning of notes, you already have A sub n. How to get to the nth term of a geometric. You start with the first, but instead of adding n minus 1 jumps, to get to the next term, which is what arithmetic did, we're going to do times n minus 1 exponents of r. Because to get to, for instance, the fourth term, aren't we going to do times r 3 times? Or multiply by r cubed. To get to the 10th term, a1 will be multiplied by r to the 9th. To get to the 100th term, a1 will be multiplied by r to the 99th. So every time to get to the nth term, I just have to say, take the first term and multiply by n minus 1 jumps of r. Common multiplier. multiplication, or I should say repeated multiplication, or exponents. So if I have directions like find the 12th term of the geometric sequence, I could do times... Hold on. Wait. Didn't we just say that we can just make little ratios? I mean, the subtraction, that's like, I don't know, what, 60-ish? And that one's like 20-ish. Yeah, no, they're not the same. But what's 24 over 96? Or what's 6 over 24? Well, I know this one, 6 over 24 is 1/4. Is that 1/4? 4 times 80, 80 and 16 is 96. Oh my goodness, that's 1/4 too. What's my common ratio? I get from my first term, 96, to my 12th term, how many jumps of times r am I going to do? Let's do the 12th term. 11.
Come on, guys.
So I can say this is the same thing as 96 over 4 to the 11th. You could plug it in your calculator. I'm too lazy. But what if it says instead, find the indicated sum, nth. I don't know why there's the word sum there. Typo. Nth term. Sequence. They stink. And I have the second term, and I have the third, fourth, fifth term. How am I supposed to figure this out? What do they tell me? It's geometric. So there's some r that's being multiplied here. I don't know this guy, but who do I know? The second term. How many r's are in between that term and that term? So could I say that 3 over 64 came from 3 times r cubed? Now I'm making up my own formula, but I'm making up a formula saying, well, that came from that, but that times 1, 2, 3 r cubed. So how could I solve? Divide by 3. If I divide by 3, don't I end up with, well, the 3's reduced. 1 over 64 is equal to r cubed. Can I cube root 64? 4 times 4 is 16. 16 times 4 is 64. R is equal to 1/4. Does that make sense? 3/4, 3/18, 3. Oh, it does. But what are they asking for? So how do I go backwards? If I know 3, and if I know times 1/4 is forwards, aren't I going to divide by 1/4? And what's dividing by 1/4 the same thing as? Multiplying by 4. What's your first term? 12. Now, was there another way of doing it? The answer is basically yes. The answer is basically yes. This next page is not the answer to the question. I'm going to go ahead and show you another way of solving over here as you guys write down your nth partial sum. Because some of you, your brains like the patterns, and you're like, oh yeah, I could have gotten that. To get here from there, I needed times r, times r, times r. But others of you were like, no. Keep me safe. Give me formulas and just let me use the formulas. So as you guys are writing down S sub n, another way you could have done it is to say a sub 2, a sub n, is equal to a sub 1 times r to the 2 minus 1 is 1, which equals 3. And then you could have set up another equation for a sub 5, which would be a sub 1 times r to the 5 minus 1, or r to the 4th, is 3 over 64. You could have seen this as a system of equations and been like, okay, I could solve for r. Then I could have plugged in. Then I could have said that, okay, fine, a1 times 3 over a1 to the 4th is 3 over 64. Then I could have gotten 3 over a1 cubed is 3 over 64. Then I could have divided both sides by 3 and done that a1 is equal to the cubed root of 64, which is... Wow, something went weird. Oh, hey, 3 to the 4th isn't 3. 3 to the 4th is 81. Lo siento. So that would have been 27. Sorry, guys. I have to keep on going in my math. That was rough. I did not do that properly. I'll come back. Bye, guys. See you later. We started section 9.3, but section 9.3 is not due until Monday. Finish up chapter 7 corrections. Wow.
Will you be here seventh grade?
I should be. Try me. Unless I'm subbing, but I don't think I am.
I am shaken.
81 over A1 cubed. There we go.
Whoa, that's nice.
Jason, what are you doing?